Warning, this is a remake. Following the best Hollywood tradition, here's a program that I recorded a while ago in German. But since the new channel is in English, and I had way too much fun recording these things, here you go with the English version. By the way, if you want to check out the German original, just click the card in the upper right corner. Now, have fun!
Hey nerds! So here's Detlef and we have another project coming up. This is a giant step for everything. This is groundbreaking technology. It is a traffic lights. Yeah, of course, as you can imagine, it's not about the traffic lights. It is never about the traffic lights. Traffic lights, from a software and hardware point of view, is a tiny bit about a blink sketch, so there's nothing much to learn here. But since hardware and software are so easy, there are a lot of things I can show you on this really easy system. Talking about hardware, this is easy. We simply have a Arduino NANO over here. In fact, this will work with any microcontroller. I had a NANO lying around. And this is connected via 4 wires with this totally fancy traffic light model thingamajig. The electrical connection is pretty simple. I just used GND, D2, D3 and D4 because they were convenient there. Every one of the LEDs has its own current limiting resistor, so we simply connect the outputs from the CPU directly to the LEDs and therefore through the resistors. So the hardware is defined. Let's go into software. And here we are, right into Arduino IDE 1.8.19. I know it's the old one. Well, if you haven't watched my video while I'm still sticking with the old IDE, it's in the upper right corner right now. Maybe you want to take a look at this. For the moment, let me switch off the flickering display of the traffic lights. This is driving me nuts. So just a short check if my settings are correct under Tools. It's an Arduino NANO set. The processor is the Atomega 328P with the old bootloader. Just for my friend Carlos, it's always the old bootloader, never the new one. And the NANO is connected on COM port number 3. So let's write some codes. Yeah, we don't need that much. We need pin mode, we need digital write, and we need some delay. So let's get to it. All right, my outputs are set. I could go in and set a default state for the pins, but I won't do this because the next step in loop will do this anyway, so we'll go directly into loop. Here I want to start with the red state. So I'll go for digital write. And since the 2 is the red one, so 2, high, and the other 2 are both low. So this defines my red state. Now I need a delay because us mere humans maybe want to be able to see the state. So a delay is at hand. No, not that way. Call it 1000. So it's a second. All right, let's copy the whole shebang and do this for the yellow state. The yellow state is simple because it simply changes this to low and this to high. I can copy this again. I need it 2 more times. And yeah, you guessed it, I'm lazy because this one is a green phase. And down here is a yellow phase again with a delay at the end. Okay, that's it. Let's move it into the CPU and see what's going to happen. And will you look at this? It's a traffic light. Well, I never expect... Okay, come on, I stop here. You're probably asking yourself right now, why am I showing this? This all comes down to, when is my code good enough? I think I spent about 2 minutes writing the code right now, and it's doing what it should. So I'm finished, right? I mean, the thing is doing what it should, so I'm finished. Maybe. Just imagine yourself looking at this piece of code in, say, 6 months. You have no idea what pin 2 does, what pin 3 does, what pin 4 does. So this is really hard to follow what stuff does. Another thing could be, maybe you want to add a second traffic light and you want to be somewhat independent of the code that's running right now. You know, delays are bad. So what's going to happen in the rest of the series? I will show you different ways to write stuff like this. The beauty of all this is there are no wrong ways. If you're just looking for a traffic light controller like this, you're done. Thank you for watching. You're finished. If you want to follow me down the rabbit hole to write this in a more obscure way, you're very, very welcome. And I promise you, this is going to be worth your time. That being said, let me do some really, really quick optimizations here, so we'll get some out of the way and can dive into more interesting stuff in the next episode. One thing is making the stuff more human readable. I said this before, nobody has an idea what pin 2 does, pin 3, pin 4. This isn't declared somewhere. So we could do that. There's this nifty thing that's called define. It's a define written like this with a hashtag in the front, and we could define LED red over here. I do this way. And we simply say, okay, this should be number 2. Doing the same with LED yellow and LED green. Yes, this is 3 and this is 4. What we're now going to do is replace all these 2, 3, 4s in the code with LED R, LED Y, LED G. So let's do this. So this looks way more readable. Now we know that the red LED is the upper one, the yellow LED is the middle one, the green LED is the low one. And one of the big upsides here is if you ever change the pin out, say you want to move this because you have 2, you can go for 5, 6, and 7, and all the pins move at once. You don't have to change anything in your code right now because it just changed the defines and all the code will run on 5, 6, and 7. There's another way to do this. We also could say const uint 8 type LED R is a 2. In our example, this would do exactly the same. There's no difference in here, especially because the compiler will probably see it's a constant, so it will replace all the occurrences of LEDR with a 2, so the code will be 100% the same. So what's the difference between this one and this one, you ask? With the keyword define, we simply tell the compiler, anytime you see the sequence of chars LED_R, simply replace it with a number 2. This is done in a pretty dumb way because the compiler scans the whole document. If it sees somewhere LEDR2, it simply replaces every occurrence with the number 2 in this case. The what to replace with part, so the 2 in this case, doesn't have to be a short one. You can put a whole sequence of commands in here and simply have them replaced with LED_R. The keyword const over here declares, as the name suggests, a constant. It's something like a variable, but you can't change the value of the variable. So what's the upside here? The type is the upside. In a constant, I always tell the compiler what type the constant is. So if I'll put in here a float, we'll probably get an error because the compiler can't put a float into a pin mode. So the question remains, what to use when? Some people say, well, define is an old school way to do this. This is just a C relic from the old times. For simple stuff like this, I pretty much like my defines over here. The type over here is pretty much not critical. I could also say the classic Arduino speech int over here. That would work too. The pin mode and the digital write commands, they're pretty much happy with everything I throw at them. So for this case, I can live with defines. Of course, there's a fourth value we can define here. If we go define wait time and set it to, say, 1000. Oh, no, not that way. We can replace all the delays with this defines. If we now want to change our time in between the flashes, we simply go up here and simply change this to, say, 2000. Let's do a quick compile run and see if it works. And as expected, our traffic lights now have a delay of 2000 milliseconds between every state change. So yeah, that was an easy one. So this is it for part 1. I hope you enjoyed this little adventure into traffic lights, and I promise you it will get more interesting in the next episodes. Stay tuned and I see you in the next one. Bye!